And as would typically follow from learning how to graph linear functions, now we're going to learn how to write them. So the first thing we need to start off with today, besides you absorbing what I'm asking you in the essential question, is that concept of slope. So here we have a picture with our ordered pairs where here is one point on the graph and here's the other, and we want to find the slope between those. Slope is going to be, if you have those two ordered pairs, x1, y1, and x2, y2, with slope being rise over run, you're going to use your formula, which would be if you subtract the difference of the y's over the difference of the x's. The question always, always, always comes up of, does it matter whether you do y2 minus y1 or y1 minus y2? The only thing you must make sure you do is that if you do y1 minus y2, you have to do x1 minus x2. So I don't care if you flip-flop them, but if you flip-flop them, you have to flip-flop them both. Otherwise, you're going to have the wrong sign on your graph. So let's take a look at finding the slope of some lines. So we have here 3 different lines. We got a red line, a blue line, and a green line. So let's start with the red line. Red line goes from here to here. Now, could we figure out that that first one has an ordered pair of -5, 5, and the second one is -8, 9? Absolutely. But instead, it's much easier if you just say, okay, to get from vertically, from here to here, because we're going from here to here, that's a difference of counting squares. That's 4 squares, but we're going down, so it's negative. And then we want to go from here to here. And when I do that, I get 3 to the right. That means that my slope for the red line is going to be -4 over 3. Let's look at the blue one. Blue one, we go from here to here. So my vertical change is from here to here, which as you can see by counting is only 1 square. And then my horizontal change is from here to here, which is a change of 6. Both of those are positive because we go to the right and we go up, because I always look from left to right because that's how we read books. Therefore, our slope of the blue line is going to be 1/6. Finally, we've got this green one. Go from here to here. My vertical change goes from here to here, which is going to be down 3. And then my horizontal change goes from here to here, which is going to be 1, 2, 3, 4, 5, 6. So then we have that the green line, that the slope is going to be -3, 6. Well, what do you notice? I notice that -3, 6 can be simplified. So that means I always want to simplify. This will be -1/2. And we always want to simplify because then we can take note that if I added extra points in, if I went down 1, right 2, down 1, right 2, I would be able to add extra points on my graph, which does come in handy. Next, we want to go back to our good old finding the slope from a table. This we've actually already done. You just didn't realize it. So to do this, we want the change in x and the change in y. And here we go up, and this is where it gets confusing. From -5 to +1 is a change of +6. From 1 to 4 is +3, and 4 to 9 is +5. From -9 to +3 is up 12. From 3 to 9 is +6. And from 9 to 19 is +10. And a lot of people want to make the argument, well, that's not a constant rate of change, so therefore it's not linear. But it is. What you have to look at then is the change, and you'll see me use this symbol. Triangular delta is change, so the change in y over the change in x. Well, the first one is 12 over 6. The second one is 6 over 3. The third one is 10 over 5. And what I immediately notice is that no matter which one we have, these all equal out to 2 over 1, which means that my slope is 2 over 1. So they don't have to be written the same, but they have to all be able to simplify to the same thing. Then we look at being able to write the equation from a graph. This is where sometimes you'll have points on the graph, sometimes you will not. Here I look and I see first I have my y-intercept here, and then you have to look for where the graph crosses two grid lines and make sure it's consistent. So I see here, and that means if I go up 2 over 1, up 2 over 1, I'm seeing that it keeps on hitting the graph, so I know that my slope must be 2 over 1. And my y-intercept, or my b, is -4. So that means when I write my equation, I have y equals my slope of 2 over 1, or 2x minus 4. Easy as pie.
My recommendation would be to do exactly what Mr. Forrest did and find our m equals something, find our b equals something, so then you have a visual of, oh, m is this, b is that when you're writing that final equation.
And that'll help us too if you're making mistakes in writing that equation and figuring out where it is you're going wrong. Finally, we have with straight up slope-intercept form, if you have a slope and the y-intercept, slope, remember, is m, y-intercept is b. I'm labeling them just like we did above, and then we write our equation. Y equals our slope of 3 times x, do not forget the x, plus a y-intercept of 2. And we're done.
The other option on that one is that if we can write our equation, y equals mx plus b, that might help some of you to actually visualize, okay, now all I have to do is substitute in for the missing m and b.
Yes, that is an excellent point. Now sometimes you're going to get a problem like we have in letter E, where you have a slope and a point, and that's where something called point slope, hence a slope and a point, comes in handy. This is going to be in the form of y minus y1 equals m times the quantity x minus x1, where the point is your x1, y1, the x and the y in black stay x and y, and your m is your slope. So if we look here, I like to label them. This is x1, y1, and this is your m. And so then if we want to fill it in, I like the color code to make sure everything's the same. So y, and it is minus. The only time it will be plus is if your point is negative. So we have y minus 1 equals our m of 3 times x minus our y1 of 1. Now we can't leave it like that because it says we want slope-intercept form. So now we need to solve for y. The first thing we need to deal with is parentheses. So we will distribute the 3 into the x and the 1, so we get 3x minus 3, and that equals y minus 1. And then we have to solve for y. We're not solving for x, so we're going to add 1 to both sides, which will then give me a final answer of y equals 3x, and then -3 plus 1 is -2. Be careful with your negatives. Use a calculator for crying out loud if you have a hard time with negatives. Don't make it any harder on yourself than it needs to be. So now, we got a couple of try problems. First one, here's your graph. I want you to put your points on it and write the equation and enter it in. Then you've got two, one with a slope and a y-intercept, and one with a slope and a point. And make sure you're putting those questions into ClassMeet. It'll make our lives a lot easier if you have an opportunity to put them in there so we can see them ahead of time. And have a wonderful day.